Lewis acids and bases. So Lewis acids and bases give us the broadest definition of acids and bases. And we look at Lewis acids as an acceptor of an electron pair and Lewis bases as donators of an electron pair. Now, rather than thinking of them as just any old electron pair, it's important to think of the electron pair as a lone pair. And so what happens is that when a Lewis acid and a Lewis base come together, they form a coordinate covalent bond. So just to remind you, a coordinate covalent bond is a covalent bond that forms when one atom provides both of the electrons. So in this case, the Lewis base provides both of the electrons. And it's stable for two reasons. It's always two reasons. One, both atoms have a stable electron configuration. They may already have had a stable electron configuration, so they don't lose the electron configuration. And then remember that bonded electrons are attracted to two nuclei, and so that increases the force attractive. Rather than that lone pair on the base being attracted just to that one nucleus, it's now between the two nuclei of the acid and the base. So here's an example. I have NH3, and the nitrogen has a lone pair right here. And if I add a hydrogen ion that has no electrons, the hydrogen ion just simply shares these two lone pairs that nitrogen is providing, but now these two electrons, rather than just being attracted to nitrogen, are now attracted to hydrogen's nucleus and nitrogen's nucleus. So it's stable because now I have that increased force attractive for those bonded pairs. So here, NH3 is the base because it has the lone pairs. It provides the lone pairs in the coordinate covalent bond. And H plus is the acid because it simply adds the extra nucleus that lends stability to that now bonded pair. So it's broader now because now any molecule with lone pairs could act as a Lewis base. Ammonia, even polyatomic ions, right? Cn minus. And any molecule or ion that has an empty orbital can act as a Lewis acid. So any cation, or even something like BF3, where you at first only have 3 electrons, but you're on the second energy level, so you actually have space for other electrons to go to. So if I'm looking at the Venn diagram of acids and bases, all Arrhenius bases are Bronsted-Lowry acids and bases. All Bronsted-Lowry acids and bases are also Lewis acids and bases. But it doesn't go backwards, right? Not all Lewis acids are Bronsted-Lowry bases or acids. Not all Bronsted-Lowry bases or acids are Arrhenius acids or bases.